if a pilot is flying around the curve of the Earth, then he should be dipping the nose down every 5 minutes. He should be dipping the nose down to stay around the curve. But the thing that really got me interested was, as you say, the gyroscope. In a plane there is a artificial horizon, okay, and it's based on a gyroscope. And if you spin a gyroscope on a surface, it will want to stay upright. You can twist and tilt the surface as much as you like, the gyroscope will stay upright. So if a plane has a gyroscope and it starts following the curve of the Earth, the gyroscope would stay upright, which means the artificial horizon will start to roll backwards. But it doesn't. That's absolute proof that a plane flies over a flat surface rather than a curved one. Because I asked the pilot on my last flight, you know, do you ever notice the artificial horizon rolling backwards? He said, no, but the artificial horizon has complex electronics in it to make sure it knows where it is on the Earth and it compensates. But I went to the manufacturer of the artificial horizon and they confirmed to me that it's completely mechanical, nothing electronic in it whatsoever. So it's literally just a gyroscope that can freely move. So that right there is proof to me that you know, planes fly over a plane. None of it makes sense. The problem is that we're taught as children, you know, this ball earth lie. And, you know, you might ask as a child, you know, what about the people in Australia? You know, they're standing on the bottom of the globe, won't they fall off? And your teacher says, no, gravity. And you go, oh, okay. And you never go back to that question. But when you go back to it as an adult and start looking at it with a critical eye, right, the whole thing falls apart. As you say, the globe is spinning at 1,000 miles an hour. Neil deGrasse Tyson, who's a leading astronomer in America,
I'm Neil deGrasse Tyson, bitch.
Tells us that the Earth is not a perfect circle, it is actually an oblate spheroid, it's squashed and wider at the equator. Yeah?
So Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate, and officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
So my question to him would be, why is there land at the equator? Because water will move more readily than rock. So if the Earth is spinning, the water will be collected at the equator. I mean, if you spin a wet tennis ball, okay, you spin a wet tennis ball, the water shoots off at the equator, essentially. So all the water will be gathered around the equator. So why is there land at the equator? Doesn't make any sense. The other thing that's about the spinning Earth is looking at the stars. Now, directly above the axis of spin is the pole star, Polaris, okay, directly over the North Pole. And we're told that the reason that all the stars spin around the North Star is because the Earth is spinning at 1,000 miles an hour. Okay, seems to make sense, because if you put a long exposure camera pointing at the North Star, you'll see the stars will make perfect circles around, perfect star trails. The only problem is the Earth is also orbiting the Sun at 67,000 miles an hour. Okay, the Sun is moving, dragging the Earth and all the planets up that way or that way at 600,000 miles an hour. So why do we see perfect circles? You know, because that's the slowest speed, that's slowest motion in that mix, And yet the Earth is moving 67 times faster that way and 600 times faster that way. So you should see the stars do all sorts of strange motions, but you don't. You only see them make these perfect circles. That tells me that it's the stars that are moving, not the Earth. The thing is, what the scientists will give you is calculations and and theories why that happens. But we have experience. We see things and they either make sense or they don't make sense. And what the scientists do is substitute our common sense and our intuition for calculations and theory. And we're supposed to believe the calculations rather than what we experience ourselves. There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. Now, the Bedford Levels is a canal that is perfectly straight for 6 miles. Okay, so what a chap called Samuel Rowbottom did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend, in a rowboat with a flag on the back, row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance. Now, according to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 5, 25, times 8, which is 200, works out, that's 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon. He shouldn't have been able to see the boat. Now, the scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, it's perfectly flat. And he in his book, he puts forward many arguments that show that, or many experiments that show the Earth is always perfectly flat. They say that you see the mast, go down last. It's literally just the way your vision works. Yeah, it's perspective and atmospherics basically. The limit of your vision is supposedly 3 miles. And then after 3 miles, you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again says that, explains that you can't see the curvature of the Earth from a plane. He says this, you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature. Yet, you can apparently see a boat go over the curvature over the distance of 3 miles, which doesn't make sense. The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out of the sight of your binoculars, if you get a telescope, it comes back again. It doesn't go over any curve of the horizon. What we found, many people have done experiments with very high-powered zoom cameras, and they've watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears and and the top of the boat inverts, so you see a sort of mirror image. And that, with your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometers away from the spire. So that should be over a mile below the horizon, and you can still see it. There's been a few famous examples just recently of a man who took a picture across the Great Lakes from Michigan and was able to see, I believe it's Chicago, which he shouldn't have been able to see. And the television station basically said it was a mirage.
This is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
But They always say it's a mirage, but for a mirage to happen, you have to have very specific atmospheric conditions. And there have been so many people who've seen exactly the same thing on different days, different seasons, always the same. You know, it's not a mirage. It's simply that you're looking across a plane. You see in a kind of pyramid shape. Yeah, you have a horizon at your eye level, and everything above the horizon will go down into the horizon. Yeah, everything below the horizon will seem to go up. Just like if you're in a long hallway, you'll see that the walls will start to move in, and the roof and the floor will start to move into the centre. Yeah, so literally between you and the object you're looking at, there's all sorts of things, sort of like waves going up and down, and while you can't see them if they're beyond the limit of your sight, they're still, sometimes they can still obscure what you're looking at. But it's just because they're between you and it, and it's just the way, it's literally perspective. It's better if I could draw a diagram, but it's a very difficult subject to get your head around if you're not used to it. But it is perspective. One sort of other proof is there's a place in Bolivia called Salar de Uyuni, which is a salt flat. It's literally 100 miles wide one way and 80 miles across, and it's perfectly flat. When it rains, literally you get an inch of water, and it looks like a perfect mirror. Now, how does that happen on a sphere? Yeah, it shows you that, you know, if you're one end of this salt flat, you can see perfectly clearly the other end 100 miles away. So it's just showing you that you know, the Earth is flat, and without the effect of the waves in the sea, you'll be able to see a whole lot further. If you were to go to NASA and download one of their photos of the Earth in the moon's sky and put it in Photoshop, okay, drop the saturation and the levels down, you'll see that the Earth has been pasted in, because you'll see a rectangular box around the Earth. It's all fraud, it's all fake. Pretty much everything NASA puts out is fraudulent. There are no images of Earth from space. The only one that NASA actually claims is a photograph was from 1972, and it's the famous picture. It's got Africa sort of near the top, and it's the same picture they've been using for the last 40 or 50 years in every textbook.